this is exactly where we left off. We're talking about Chapter 4, Section 1. So I'll name this video 4.1b. And yeah, what I'm going to do next is solve by substitution. Now remember, substitution is just a fancy word for replace. Just like when you have a substitute teacher, it replaces, or she replaces your regular teacher. And basically what it boils down to is if you have a variable by itself, which y is by itself, maybe I'll use a highlighter, y is by itself, then what you can do is look at the other y in the problem and replace it with what it's equal to. So how about I do this? I'll go back and rewrite this as 2x plus, and just take out the y, because that's what has to happen before you get a substitute, is your regular teacher needs to go away and then replace with what it's equal to, the 4x plus 7. Now, in a lot of substitution problems, you'll probably have to distribute, but there's nothing to distribute here, so we can actually skip that step. And 2x plus 4x is 6x, plus 7 is equal to 4, so subtract 7 over, and 4 minus 7 is negative 3, and when you divide by 6, this reduces to negative 1/2. 3 over 6 reduces to 1/2. But you're still not done, because remember, and this is why we teach graphing first, is your answer needs to be an ordered pair. It has to be a point of intersection. And you can go to either of these two equations and just, I think it's faster to go to the other equation that you haven't messed with yet. And type it in there, and half of 4 is 2. A positive times a negative is negative. And when you add 7 to negative 2, you get that y is equal to 5. You can leave your answer like this. You'll probably see me write it as an ordered pair, because I think that's a good habit to be in, to identify that it's a point of intersection. So right here's your answer. All right, feel free to pause before I move on to the next page. So I threw in some fractions in here. Not trying to scare you at all, but that's what we have going on. Sorry, my fractions don't always look like fractions. Now what some people do is they don't like the fractions, so they actually solve, get the same denominator for all of these, which I don't know if that's really advantageous, but you know, for instance, you could multiply everything by 4 in this bottom equation. So as I'm distributing this 4 into everything, the x over 4 times 4 would cancel out the 4's. Now 4 divided by 2 is 2y is equal to negative 1. And now I'm going to do this slightly different. I'm going to get x by itself, because the previous problem had y by itself. So let me identify what I'm talking about. Is once you get a variable all by itself, you can replace it in the other equation with this value. So I can go to this top equation and replace that x with 2y minus 1. And maybe I'll just stick with that same color. I did not give myself much room, so hopefully you're okay. Like you have enough room on your piece of paper. Notice that I have to have this written out. Let's go ahead and do my suggestion earlier and get the same denominators. So what you could do is your common denominator here would be multiplying everything by 12. So 12 divided by 3 would make that negative 4x. And then 12 divided by 4 would make that 3y. And then 12 divided by 2 makes that 6. So let me go back to my red. I think this is smarter anyway. I can go to this x and replace it. And you know how earlier I mentioned the distributive property? Whoops, I forgot to write my 4. Negative 4, replace x with 2y minus 1 plus 3y is equal to 6 now. And distribute. So we're at negative 8y plus 4 plus 3y is equal to 6. So I'm going to do two things. I'm going to combine like terms. That's negative 5y. And I'm going to subtract 4 to the right side. 6 minus 4 is 2. And when you divide, you can leave it as that reduced fraction, negative 2 over 5. Or if you change it to a decimal, I'll be fine with that. But you're still not done. I'm going to go back to green. Because remember, your answer is an ordered pair. So that means that x is equal to 2 times plugging in negative 2/5 in for y minus 1. And that tells me that x is equal to negative 4/5 minus 1. I'm going to change 1 to be 5/5. So then you understand that it's x equals negative 9/5. There we go. So I knew I didn't give myself much space. But that is your work for number 5. All right. Remember, it's an ordered pair, negative 9/5, comma, negative 2/5. Now, after going through all that, substitution is a lot of work sometimes. I think you would agree. Elimination sometimes is a lot better. And what elimination is when you add pieces together. Now, I'm sure you guys remember from previous math classes that when you match things up, you were able to just cancel them out and cross them out. But I want to talk for a second why that works. Is because these two things are equal to each other. So what I'm saying is 3x minus y is equal to 5. Well, the premise is that you can add equal things to each other. So since 5x plus 5x plus y is equal to 11, what I'm saying is if you add this piece with this piece, it's the same as adding this piece with this piece. A lot of teachers tend to not explain this because students why this answer works. But let me just highlight for a second that, oops, I was about to erase, that this piece is equal to this piece. So those two are equal, and then this is equal to this. So adding equals to each other will still be equal. There's your equal right there. Let me highlight your equal right there. So that's why this method works, and that's why when you combine things together, negative y plus y will cancel each other out. And that's why traditionally some teachers will look at this and say, oh, you can just cancel these out, and you're left with 8x on the left side equals 16 on the right side, which is the exact same thing as what you would have gotten on this thing. 3x plus 5x, by the way, is 8x. 5 plus 11 is 16. So I just wanted to talk briefly about why elimination works. But most of you probably don't care. You just want to get the right answer. That's by dividing 8 over and you get x equals 2. But you're not done because you need to plug this value in somewhere in here. I'd probably go to that bottom equation. 5 times 2 plus y is equal to 11. So that's 10 that I'm going to subtract over. So y is going to equal 1. So your ordered pair is 2, comma 1. Yeah. Now, elimination is not always this easy. For instance, if I ask you to use elimination here, do your y's or x's match up? No. Now, there's a surefire way of always getting the right answer, and that involves always matching up either your x or the y. And in my experience teaching this to students who are learning it for the first time, they understand that if I just multiply the top equation by the bottom's coefficient and the bottom equation by the top coefficient, then they'll always get the right answer. Now, we do have an issue here because if I just multiply them out, let me write it out real quick, 12x and 12x. Well, right now they're not going to eliminate because if I add them together, I'll get 24x. Well, let's fix that. Let's make one of them negative, and it doesn't matter which one. I'm going to make the top one negative. So now when I add them together, I get 0x. Will they cancel each other out? Yes. Now what you have to remember is that you have to distribute that negative 4 to every term. So this turns into plus 8y equals positive 24. And then the denominator here, I get 15y equals negative 24. And so now you can eliminate your x's. On the bottom, that looks like it's 23y. Oh, but 24 plus negative 24 is 0, so if I divide that over, y must be 0. But you're still not done. Go to one of these two equations, and it doesn't matter which one. I'll just go to the bottom. I'm usually good about color coding it. And what I like about this is 5 times 0 is still 0. Adding 0 is like doing nothing. Is equal to negative 8. So as I divide 4 over, my answer for x will be negative 2. Perfect. All right. Exercise 8. Again, feel free to pause or try a problem on your own before watching it. If I follow that same advice and I multiply everything in the bottom, now here's the thing. A good problem solver will not automatically just multiply top by 2 and the bottom by 8. A good problem solver will look at this and say, well, if I just multiply this by 4, I'll get the variables to match up. So, for instance, that 8x plus y equals 6, this top equation, is not going to change. Well, if I just do 4 times 2, that's 8. Now remember, that doesn't cancel them out because 8x plus 8x is 16x. But you can change that to be a negative, and that'll fix your answer. So as I distribute that in, that would be negative y because the 4's will cancel. And negative 4 times negative 2 is positive 8. So, now that I'm looking at this, these cancel and these cancel. So you're left with 0 on the left side, and on the right side you're left with, that's equal to 14. That's a false statement. So elimination will, if you get a false statement, will get you a value that says that there's no solution. So remember, because we did graphing in the previous video, what does this actually mean? Is that these two lines are parallel to each other. So you don't need to see a graph to be able to deduce that there's no solution. There's no points of intersection. That's why we call them parallel. I believe there's just a few more problems. Yep. So you could probably bet if one was no solution, the very next one's going to be infinitely many solutions. Which if I show you on this one and multiply the top one by 3, I think you'll see equals negative 3. And by the way, you don't have to rewrite it. You could just write it right there. But a good habit to be in would be to rewrite the second equation as if you multiplied it by 1. And what you'll notice is the x's cancel, the y's cancel, and these cancel. So you're left with 0 equals 0. This is a true statement. So that means that these two lines are the same line, which means that there are infinitely many solutions. That means every point on the line is a solution. So notice we're basically asking, is it a true statement when everything cancels, or is it a false statement? If it's true, there's infinitely many. If it's false, there's no solution. And then your last problem, you can read all these words. I would actually encourage you to pause it and make sure you read all these words. But the main thing is you have the two equations, y equals 17x and y equals 6x plus 80/30, excuse me. And I would just do straight up substitution because they both equal, whoops, I almost erased it again. Both equal the same thing, so they must equal each other. So 17x must equal 6x plus 80/30. Subtract 6x over, you're at 11x equals 80/30. When you divide by 80/30, use a calculator. I think I said that wrong. 80/30 divided by 11 is 730. All right, now just keep in mind that this is answering the question because x represents the number of units. I could easily change this problem and just say, and also find what the cost is before you break even. Well, how do you find that? Is take this value and plug it in for x. 17 times 730 will give you that answer. That's just a heads up for how questions can differ on future assignments. But you should be ready for your homework, and I'm about to get cut off on my video.